Hello. Hello, teachers, and hello, faculty. Hello, everyone. Today is Teachers' Day. Happy Teachers' Day to one and all. And we thought that we have to give you something in reciprocation for the teachings that you have been doing all these years relentlessly. You have been pivotal in terms of upskilling the students. The knowledge that you possess in a selfless manner, you have been disseminating this. You have been sharing your learnings, your knowledge that you have gained over the period of a few decades to the students. And these students are tomorrow's workforce who are going to drive the country. So we thought, as part of this Teachers' Day, we will try to plug the gap between academia and industry. Usually, what happens is academia says that industry people are not collaborating with us to help us understand what real world projects happen. On the contrary, industry folks keep saying that academia is not delivering teaching which is relevant to industry. So, always there is this tug of war between academia and industry. So, we thought we will plug the gap between academia and industry. And how are we going to do that? We are going to do that by explaining you all about all the real world projects that we have accomplished so that all the teachers and everyone watching this lecture gets a fair bit of understanding on how real world projects are handled. And hopefully, these details can be used in the training curriculum. Okay. And hopefully, there will be a lot of learning which will help us tweak the curriculum a bit to suit the needs of the industry. Welcome once again, and I think we can embark on this journey. So let me share my screen and get started. For that, I think I would, yep, I have, okay, let me share the complete screen. Okay, once again, a happy Teachers' Day from AI Spry and 360DigiTMG. AI Spry is into AI services. We also have an AI-driven learning management system. And 360DigiTMG is into trainings. We are extremely focused and extremely specialized in delivering trainings only in the space of artificial intelligence. We deliver trainings in the space of data analytics, data science, data engineering, MLOps, and generative AI. We also do projects as part of AI Spry, but we deliver projects only in the space of, again, data analytics, data science, data engineering, MLOps, and generative AI. We are extremely focused. We do what we teach. We teach what we do, right? That is how focused we are. And probably this is one reason why a lot of students who actually get trained through us and do internship projects with us are eventually getting placed in a lot of top-notch companies. So let's look at how do we handle the projects end to end. We will look at AI projects and we'll also look at generative AI projects. Okay. I would also like to showcase a few quick things on how the entire structure would be. And then we will move ahead, right? So just in the interim, please have a look at this. Okay. So this clearly, I believe, demonstrates that we are going to talk about video analytics projects as well. Okay. So this is how the entire system would be, friends. If you were to go to 360digitmg.com, you will find learning resources on the menu. When you click on learning resources, and if you scroll down a bit, you will see core learning resources in which we have a book, AI architecture. You can assess yourself on whether you can clear the interviews or not, students, I mean. Then we have resume optimization hub, which will actually help you create your resume properly. You also have talent connection portal, which is all about the job opportunities that we have got directly through the companies, or we as AI Spry also might be having certain openings. And then we have mind maps, innovative project showcase, and animated learnings. I would like to go to this animated learning, and I wish to show you something very interesting, which is called as Crisp MLQ. This Crisp MLQ is extremely critical and extremely important for anyone who wants to do projects in the space of artificial intelligence. The journey starts here. Okay, so this particular Crisp MLQ has 6 different phases. I'll talk about these 6 phases at a high level, and then I'm going to explain each and every project in the view of this framework. This framework will help you handle your AI projects, and it will also increase the success rate of your projects. Okay, so that would be our focus. Let me take the screen brush so that I might write. Okay, so it has 6 phases, Crisp MLQ, as you see here. Phase 1 is business and data understanding. Phase 2 is data preparation. Phase 3 is model building. Phase 4 is evaluation. Phase 5 is deployment. Phase 6 is monitoring and maintenance. Even before you start any AI project, first of all, you need to understand what is the business problem. What is the problem that the customer has or the company has for whom you're doing these AI projects? Then you need to define what is going to be your business objective. And this business objective should have a clear linkage with the business problem. And also, how would you conclude that your project is a success? Who is going to say that your project is a success? For that, you need to define the success criteria. Success criteria is extremely important. We have 3 success criterion. Number 1 is business success criteria. Second is machine learning success criteria. And third one is economic success criteria. These are extremely important, okay? Only after you are clear with the business understanding, you move on to data understanding phase. As part of data understanding phase, you go and collect that data which is needed to solve your business problem. Collect the data to solve the business problem. Okay, that's very important. Then, once you have the data with you, you need to proceed further with exploration. Okay. You don't just collect the data, but get a very good understanding of your data. So as part of this data understanding, one more very important step is explore the data, which is famously called as exploratory data analysis. Once you explore the data, based on the exploration results or insights, you perform data preparation. Based on the insights that you get, you perform data preparation. You pre-process the data, you prepare the data. And once you have the right data, then you proceed further with model building phase. Okay, you proceed further with model building phase, where you first of all have to select what is a model, okay, and how would you define the success of model building, the success of machine learning algorithm usage. How would you define the success? Success is not just based on accuracy. A lot of people assume that when I build a machine learning algorithm, I need to build an algorithm which provides maximum accuracy. That is important, but that is not the only success criteria. Yeah. To decide whether your machine learning model building phase is complete or not. So alongside the model accuracy, you'll also have to look at the other aspects such as performance, speed, robustness, scalability, explainability, so on and so forth. All these aspects should be considered when one builds a machine learning algorithm. Okay. So there is not much that I want to explain here because I want to get into the projects and explain you the projects, right? Then you move to the next phase, which is about evaluation. As part of evaluation phase, you are not going to evaluate only the machine learning success criteria. You're also supposed to evaluate, as part of this phase, you're also supposed to evaluate the business success criteria as well as economic success criteria. Once this is done, then you proceed further to the next phase. And that next phase is called as deployment phase. If you have to give the solution to the customer, how would you give? Would you just tell that, hey, I've written Python code, go take it? You won't do that, right? So what do we do then? We actually deploy on cloud, or we deploy the solution on premise on a mobile application, or you might want to provide the machine learning solution or AI solution, or you might want to put your model in a CCTV camera or in one of the IoT devices. It depends on the business problem that you're trying to solve. Once this is done, you're not done. This is a beginning, right? Though it is a last phase, you are expected to continuously monitor and maintain the model. Continuously. You need to monitor whether the accuracy is same or is it dropping. Is the data on which you build the model the same or did it change? Okay. So monitoring and maintenance becomes extremely critical and extremely important. So this is a high level framework that one should be very aware of. Then you also need to remember one more thing. Let me show you that, which is going to be extremely important. Once again, you just need to open 360digitmg.com. The moment you're on this page, click on learning resources. And under learning resources, if you scroll down, you'd see code learning resources. In this, AI Design Studio. Okay, AI Design Studio for ML. You need to click on design your ML model. Here you have beginner, intermediate, advanced. There are three levels which are available. Okay. And you go with beginner if you are a new person to this field. Here you have a lot of workflow element stored. Okay, a lot of workflow element stores are there. How would you perform data collection? What are the various databases that exist, right? If you look at this, data sources, you can just drag and drop. Say I want to conduct survey and questionnaire, or maybe I have data coming in the form of images and videos, right? Where will you save it? Where will you save that data? Maybe you might want to use Amazon S3 bucket. Maybe you also want to use NoSQL database. Yeah, you decide what makes more sense. Then, what kind of EDA data pre-processing do you want to perform? Okay, you can just look at domain specific feature engineering. You can look at dealing with outliers, so on and so forth. Then, what kind of models are you going to use? Would you use supervised learning, unsupervised learning? What would you do? Do you also want to split the data? Because as part of model building, you actually have to also split the data into training and test. So, okay, maybe you might want to split the data into training and test. Then what techniques do you want to apply? Since these are images, maybe you might want to select a few black box techniques. Okay. And then you proceed further with model training and hyperparameter tuning. Because what would you do? What kind of hyperparameters would you select? Maybe you'll select cross validation, maybe you'll select batch norm, so on and so forth, right? And then you move on to model evaluation. How are you going to evaluate, right? So cross validation, I would like to bring it here. This shouldn't be there, but that's okay. Yeah. And then probably you'll try out some other techniques here. Then this is like a quiz, okay? This is like a quiz. Whatever are the relevant things, you have to drag and drop and then click on validate. Then it will tell you whether your validation is right or wrong. Then probably you want to do a cloud-based deployment. Okay, after your cloud-based deployment, how would the end users use it? Probably on the mobile application. Now I'll click on validate. After you click on validate, you'll come to know whether the validation is a success or a failure. If it shows one of these in red color, that means those things shouldn't be there. Okay, otherwise things are fine, and then you can click on export, and the architecture will get exported. There we go. Use this architecture as reference. All right. You can expand the scope. You can go to intermediate. There'll be even better and advanced stuff available here. Go to advanced. You'll have even better stuff here, right? So it's up to you on which one you want to use. This is also extremely important. So you need to first remember what is a framework. Second, you need to understand the architecture of your entire project. Now, let's go and explore a few projects. This knowledge is sufficient at a high level, and you can absolutely take it further. Okay. So this is one of the projects that we have solved, okay, for one of the automobile companies. This is called as automotive assembly line, and we want to reduce the cost of poor quality. What does that mean? Right? If you see, this person is bringing the engine chassis to the clamping station. He's putting the engine chassis there and closing the clamps. If you observe, this gentleman would be closing the clamps. So what? What is the business problem here? Remember the CRISP MLQ framework, which is very, very important. So first, you need to understand what is the framework that you need to apply. The framework that you need to apply is CRISP MLQ framework. Okay. In this, phase one is business problem understanding. So I'll call it as business and data understanding, which is phase one. In this, the business problem, which is the first element, would be that when this person here, when this gentleman is doing the clamping, he might follow wrong sequence also. So it's something like this. All these are the clamps that you have. This is clamp 1, clamp 2, clamp 3, clamp 4. In that way, there are a lot of clamps available. There is a specific sequence in which you have to do the clamping. Only then, when you fix the engine chassis to the, the equipment here, which is usually at the front of the truck, it would be properly installed. If you follow a wrong sequence, then during quality inspection, once you assemble the entire truck, okay, once you assemble the entire truck, what happens? There will be quality inspection. Okay, you'll have quality inspection. As part of this quality inspection, people will realize whether there are any mistakes done or not. If there is any incorrect assembling which is done, assembling means fixing of the components. If incorrectly it is done, then what will happen? You again have to dismantle everything. You have to open the engine truck, so on and so forth, engine chassis, and then again correct that mistake and then again fix it, which is going to consume a lot of time. That's called as rework time. Okay, the amount of rework effort would increase. If the amount of rework effort increases, then that is called as cost of poor quality. Because you didn't do a good job, because of the mistakes, because of the wrong quality, you're doing a rework. Right? So this is the business problem. The cost of poor quality is increasing. So what will be your objective? Your objective will be to minimize or reduce the cost of poor quality. Once this is clear, you proceed further with data understanding. As part of data understanding, you go and collect the data. How would you collect the data? What data would you collect? You collect the data, which is nothing but videos. The real-time clamping, when people are doing the clamping, you take a photo or take a phone and then capture the video. These videos would be then stored in some database. Somewhere you need to store, right? So where should you store and all? You'll be able to figure out if you explore this machine learning architecture page. So step by step, we have given everything possible for people to work on real world projects. So once you have the data, you need to pre-process the data. That's the second phase, right? In CRISP MLQ. What is phase two? Phase two of CRISP MLQ is data pre-processing. Very, very important steps. As part of data pre-processing, You take the videos and you split these videos into images. Those are called as frames. Did you ever hear frames per second? You might be talking to your friend saying that my phone has 40 megapixel, 80 megapixel, etc. The more the pixels, better is the quality of the video. If the quality of the video is good, even if you have more frames per second, it will work well. So everything is related to your data collection once again, right? If you collect right data, right quality data, all the other steps in your CRISP MLQ framework would be apt. It's like garbage in, garbage out. Give the wrong quality data to your algorithm, you'll get the wrong results. Okay, so we have data pre-processing. As part of data pre-processing, you take the video, split it into frames of images, and then now comes an important part which is called as data annotation. Data annotation. Majority of the time would go into this data annotation. Okay, so what you do is you take, suppose this is one image from that video, you go to this image and you do the clamping part. Sorry. How would you do that? Let me choose a color which should be easy for you to see. Okay. You put bounding boxes like this on the image. Okay, you put the bounding boxes like that and then call it as 1, 2, 3, 4, 5, 6, so on and so forth. Okay, and you will say that only if someone first closes first clamp, then the second clamp, then the third, then the fourth, then fifth, then sixth, in that order, only then it is right sequence. Everything else, you would say it is wrong sequence. Simple. Anything else is wrong. And once you do this annotation, which will take huge amount of time, once you're done with the annotation, then you proceed further with the next phase of CRISP MLQ, which is called as model building. Okay. Once you have the data, then you proceed further. And you proceed further with something called as model building. Since you're dealing with images, you'll have different algorithms, right? So these kind of things you should be able to figure out upfront. Upfront, you'll have to figure out. For example, as part of model building, since you're dealing with images and videos, you need to apply deep learning algorithms. As part of deep learning, you use object detection algorithms. Like YOLO models, Detectron, Mask RCNN. There are a lot of transformer-based techniques nowadays which are becoming famous. You can use those. Once you're done with model building, which is phase 3, you'll move to the next phase, which is called as evaluation. In evaluation, you need to evaluate all the 3 success criteria. Remember, as part of phase 1, which is business and data understanding, we should have defined the 3 success criteria. As part of evaluation, you evaluate all of those 3. And what are those 3 success criteria? 3 success criteria happens to be business success criteria, machine learning success criteria, and economic success criteria. All these 3. Okay. After you evaluate and figure out that you have done a good job, or if you met the success criteria, then you proceed further with phase 5 and phase 6. Okay, then you proceed further with the next set of phases. What are those phases? Deployment. Okay, you build the solution, but whom would you give the solution to? And how would you give the solution to? Okay, for that, all you need to do is you need to figure out, okay, this is where the architecture diagram becomes very important. Where are you going to deploy? How will the end user use your application that you built? Okay, here is the end user device. Yep. So after deploying the model, how will the end user start using it? That is very important. So here, what we have done is, as part of model deployment, we deployed this model on IoT device. We have actually used Raspberry Pi. We made it industry grade by having proper casing and all that. But IoT devices are very small, and models that you build might be of bigger size. How would you put that model in such a small device? For that, you'll have something called as model compression techniques. Without compromising on the accuracy, performance, what you do is you compress the model. If the model size is, say, 10 MB, when you compress it, it would become probably 1 MB. So you compress it using quantization, pruning, knowledge distillation. There are various other techniques. Once you do that, the model will go and sit in IoT device. So we put it on the IoT device, for which camera also was there, and we put it on the top of each and every workstation. So if workstation is this clamping, this is the workstation. On top of this, at the roof, we put the IoT device. If someone is going to do a wrong clamping sequence, immediately a red color will glow like your ambulance color, and that would glow the entire floor here in red color. If the entire floor becomes red in color, then that is an indication for the supervisor that something is going wrong. So this supervisor or the team leader will quickly go to this clamping station and they'll try to fix the mistake. So you're trying to fix the mistake even before it happens. That's the best part, right? Then once you deploy the solution, your job is not done. You have to continuously figure out whether your model is giving good result or not. Is it continuing to give good accuracy or not? Okay. And that happens as part of your monitoring and maintenance. Monitoring and maintenance. Is the accuracy of the model. Probably when you evaluated, you got a model accuracy. In this case, we use something called as mean average precision, or you use something called as mean average recall. Okay. And not the typical accuracy measures, because this is object detection, right? There's something called as intersection over union. How much of the detected object and the actual object are overlapping, basically, right? If you don't understand, forget about it, not an issue. But you use these accuracy measures and say this was 85%. Okay. And then you deploy it. There is high chance that whenever you have the hardware components, the hardware components might get degraded because of the wear and tear, because of the excess heat. There might be some damage because these are hardware components. Whenever there is damage, the data which it collects might get skewed, might get drifted. If even if there is small scratch on the camera, okay, which is tagged to this IoT device, or if it is very cold and if there is some fog, okay, then what will happen? It will not be able to capture the video properly. And remember, what did I say? Garbage in, garbage out. If the quality of your input is not good, quality of the output also will not be good. So you have to look at your data drift. Is the quality of the data which is being supplied to the model the same, or is it getting degraded? That would eventually result into model degradation, meaning model will start giving you lower accuracy. It was 85%, but maybe now it's giving lower accuracy. How will you measure accuracy? You periodically manually check. Manually, you just monitor and see whether it's capturing the right results or not, one way. Second way is look at your model accuracy value itself, right? Keep monitoring it. This is how you deploy a model end to end. So we have looked at CRISP MLQ framework. We have looked at how do I apply that to this scenario. Okay. Now, we will move on and talk about one other business problem. And after this, I would also like to show you a few other business problems which will be slightly different than what you're seeing here. Okay. But anyways, here, this is for one of the steel distribution companies. They purchase steel rods, and when you purchase steel rods come in standard 12 meters. You can purchase the steel rods from Tata Steel, Bhilai Steel Plant, so on and so forth. They give you standard 12 meters steel rod, 12 meters in length. And the steel distributor will get orders from construction companies. We have in India My Home. You have Aparna. You have various other construction, Jayberry, so on and so forth, right? So all these people continuously are building concrete blocks, and they place an order for steel rods. To do any construction, you need it, house, apartments, whatever. And this particular company, right, steel distributor, has two options. One, take the order from the construction company, just give them the steel rods. At the construction company, at the construction site, they will download or they will take all those steel rods from the truck, put it on the ground, and they will start cutting it. Maybe they have pillars of 6 meters height. So they'll cut the 12-meter rod into two parts. If they want 4 meters, again, they'll cut it. Where are they cutting? They're cutting at the construction site. So what the steel distributor thought is, let me differentiate my company from the others. Then what they thought is, whenever we get the construction requirement, we will ask that construction people on how many meters do they want. We can cut it in our company and then send it by cutting the steel rods and bending the steel rods based on their requirements. So they need not take the standard 12 meters steel rods, and at the construction site, they need not cut it and bend it. Cutting and bending will happen at steel distributor's site itself. Here is where the important thing started. If they had a requirement of, say, 8 meters, what do? They take the standard 12-meter steel rod that they purchase from Tata Steel and they will cut it. They'll cut and get 8 meters. What about the remaining 4 meters? From 12 meters, if you remove 8 meters, you'll be left out with 4 meters. The 4 meters is called as off cut. And this off cut, they go and put it in the inventory. They go and put it back in the inventory. If someone wants 6 meters, they'd again take the standard 12 meters rod, they cut it, and if you cut 6 meters from 12 meters, you'll be left with another 6 meters. This is called as off cut, and you again go and put it back in the inventory. And no one has any clue on how many 4 meters, how many 6 meters, how many 2 meters, how many 3 meters steel rods are there in the inventory. What if they want 4 meters? They don't go back to the inventory to take the 4 meter offcut which is already there. They again take the standard 12 meter steel rod, again cut 4 meters, 8 meters will be left out. But they're not making use of the offcut. We ask them why. They're saying that there is no one to count. There's no one to keep a track of how many 4 meters, how many 6 meters, how many 7 meters steel rods are there in our inventory. Then we understood their business problem. Okay. So remember CRISP MLQ, your friend, framework would come into picture. As part of this, what is phase one? Business and data understanding. Okay, let me just fix this part. Business and data understanding. As part of business and data understanding, you need to understand what business problem. And what is the business problem here? The offcuts in inventory count is not maintained, because of which once the number of offcuts in the inventory get piled up, and if they feel that there's no space, additional space available, they'll sell it. And they sell it as scrap. The steel distributor, first of all, goes and purchases the steel rods from different companies by paying some money. When they sell the offcuts, they don't even get the money for which they have purchased. Scrap. It's a waste of money, right? So that's a business problem. Once you know the business problem that a lot of offcuts are getting accumulated in the inventory and eventually that is getting sold as scrap, thereby leading to losses or thereby leading to reduced profits. If that's a business problem, based on that, you need to come up with business objective. Your business objective will be to minimize the offcuts. Then comes the data understanding part where you need to go and collect the data. So we went there to their construction site and then we have collected all the videos. Again, we came back with those videos. Then we started doing what? Phase two, data pre-processing or preparation. As part of this data pre-processing or preparation, we made annotation, which is very, very important. What do you mean by annotation? Suppose there's a steel rod, we put a bounding box like that. We say that, okay, this is 12 mm steel rod. Okay, then we also capture the length of the steel rod. We say that, okay, this is probably 8 meters. In that way, we captured the length and the diameter. Okay, we captured the length and diameter of the steel rods. After we captured the details of length and diameter of the steel rods, or after we annotated in this way, then we move to the phase 3. What is phase 3? Phase 3 is model building. Again, you need to decide what kind of models make sense. Since this is related to unstructured data, which is videos or images, we proceeded further with deep learning algorithms. And we resorted to object detection techniques. In object detection, we proceeded further with YOLO models. Once we build the model, then we moved on to evaluation phase, which is phase 4. Let me write it here maybe. Phase 4 is evaluation. As part of model evaluation, you need to not just evaluate the machine learning success criteria, you also need to evaluate business success criteria and also economic success criteria. Economic means how much money will you save by doing this project. Okay, and also machine learning success criteria. Then you go ahead and deploy the model. Where did we deploy? We deployed it in a mobile application that is called as again edge deployment, which is mobile. As part of your edge-based deployment, when you put the model in mobile, you compress the model and put it in the mobile device. Okay, then you just take that mobile, walk around the inventory, and at the end you'll get a count on how many 8 mm, how many 10 mm, how many 12 mm steel rods exist. Okay, what is the length of each and every steel rod? All these details will come to me. Finally, we have monitoring and maintenance, which is extremely important. Okay, monitoring and maintenance is extremely important. You need to monitor what? You need to monitor whether there is any drift in the data, whether there is any drift in the accuracy. And there are various other aspects, friends. I'm not getting into the depth of all these things, but at a high level, I'm helping you understand on what happens. Okay. So this is one thing. Of course, we did a lot of additional things also. Okay. Next. Before I get into this, let's see if there are any questions which our friends have. You all, I'm sure, are there on YouTube. But then if you have any questions, now is the right time. I'll take a few questions. And the moment it is an hour, we will take a quick break and then proceed further. Look at the questions on YouTube Live, and then you can ask me here. And also towards the end, there will be a link which we are going to post. We would request you all to click on that link and give your attendance so that you all get the participation certificate. We'll be sharing with you all participation certificate. Okay, there'll be a link that we are going to provide for attendance. Okay, you'll have a link for attendance and you'll get participation certificate. You'll get an email. In that email, you will have the participation certificate. Okay. Any questions? Any of you all? I'll be more than happy to take at this point of time. Okay, so there is a question around how are these projects going to help the student community? So let me do this. Link will be posted towards the end. Maybe we'll post it, after another hour. Oops. Yeah, I'll go to 360DigiTMG. Here you have playlists in which you also have placement success stories. If you go to this, you will see hundreds of people who are our students who got trained through us and who eventually got jobs. Hundreds of people you'll see. You'll also understand that a lot of people are from non-IT background. If people from non-IT background can get a job as a data engineer or data scientist or AI engineer, then why can't you people get? Right? People who are from IT, it will be damn easy. But majority of these people, right, are people who got jobs in different companies despite being from non-IT background. Okay. So it's not that you join for the training and magically you'll get a job. No, no magic, only logic. You put in your hard work, we will help you work on these kind of real world projects and eventually you'll get placed. Okay. So let me quickly do a recap and then we will take a break and then we will join back again. So we discussed about CRISP MLQ framework. And then I've shown you something called as, let me go there and show you. That would be better, I believe. I've shown you ML workflow architecture, okay, which will give you a fair bit of understanding on how to go about your project. ML workflow architecture. And then we have looked at two examples. One is with respect to automotive, one is with respect to steel. Okay. And AI is applicable to all the industries. And this is a classic example of that. All right. So what we will do at this point of time is we will quickly take a break for 5 minutes and then we'll come back. Yeah. 5 or probably 10 minutes. So I'll put it here. We will take a break for 10 minutes and we will join back at 10:05 a.m. Yeah. Please take a break and come back at 10:05. Thank you. Hello, everyone, and welcome back. So, we have been talking about CRISP MLQ framework. Let's take a few more examples and try to firm up our understanding on this front. We worked in the space of poultry also, I'll just skip that. Let me explain about this particular business problem. Here, in this particular business problem, this is a construction drawing. Okay, it's a blueprint basically for your construction. Maybe this is a foundation, a drawing. How many pillars should be there? How should the foundation look like whenever you go ahead with house construction or any construction, civil construction, basically, right? So, people, what they do is usually they take this drawing. Okay, so let me write it here. You take the drawing and you manually convert this drawing manually. Okay, you enter the details on how many pillars you need, how many steel rods you need, what will be the diameter of the steel rod, what will be the shape of the steel rod. You get all those details and you enter these details into an Excel sheet. So you have the drawing. This is the drawing, and you take the details from this drawing and you create an Excel sheet. And this Excel sheet contains various details such as what is the diameter of steel rod, what will be the length of the steel rod, how many steel rods would be needed, what will be the shape, and various other details. When you do it manually, it takes a lot of time. Okay? And also it is prone to mistakes. If this is the case, then when you apply the CRISP MLQ framework, how would it appear? What is phase one? Business and data understanding. In business and data understanding, first thing is you need to identify what is a business problem. And the business problem is that manually entering the details of this drawing into an Excel sheet is very time consuming. It is not just time consuming, it is also prone to a lot of errors. Okay, so once you're clear with the business problem, you document the business objective. Okay, once you understand the business objective, you document the success criteria. Business objective would be minimize the manual effort or minimize the mistakes. Then, sorry, I'll just remove my video for a bit so that you know what we are writing here, right? Then what about success criteria? You'll have three things, right? You'll have business success criteria, economic success criteria, and then machine learning success criteria. You document all of that. That concludes the business understanding part of it. Then we need to proceed further with data collection, which is nothing but data understanding phase. As part of data understanding, we have got a lot of such images from the customer. And we also have taken a few from the internet. Then comes the data pre-processing part, right? Which is the next phase of CRISP MLQ, which is data pre-processing. As part of data pre-processing, we do a lot of things, including annotation. You again go put the annotation and do the annotation part, which is very, very time consuming again. Then comes the model building part. As part of model building, again, whenever you deal with images or videos, you end up using deep learning algorithms. Then as part of deep learning, we use again object detection here. And we use techniques such as YOLO, Detectron, Mask RCN, and so on and so forth. Once you're done with building the model, you evaluate. Okay, you evaluate the model. As part of model evaluation, you check again measures such as mean absolute precision, mean absolute recall, so on and so forth. But this is from machine learning standpoint. You also need to evaluate the business success criteria and economic success criteria, very important. Then comes the next phase, which is deployment. So we deployed this solution, this time not on edge. Okay. This time we have done the deployment on cloud. And people who want to use this, they just need to enter the URL, the website on the browser. They just need to upload the drawings. And the moment they upload the drawings, they will be able to see the result like this. So let me show you that. You get a table like this. Number of bars, number of elements, so on and so forth. What will be the diameter? What will be the length? What will be the weight? What will be the shape? All these things are obtained in a very easy manner. So for a few drawings, people were taking 8 hours to convert the drawing into an Excel sheet, but we reduced it from 8 hours to 8 seconds. Then the final thing is monitoring and maintenance, which is very, very important step, very important phase. Model monitoring and maintenance. Here you need to monitor whether there is data drift or not, model drift or not, so on and so forth. So this concludes yet another business problem or another use case that we have solved until now. Let me quickly have a look at the YouTube live and let me see if there are any additional questions here. There are no questions as such for me to answer, but if your question is where is the link, then our team would be posting it at around 10:30 or so. Understand it's Teachers' Day, a lot of you all are completely occupied. And if you all are really enjoying this session, do let us know. We will arrange a lot of such sessions for you all. And if at all you all are completely occupied, etc., we might want to wrap it slightly sooner than actually planned, right? We planned the session for a lot of hours, but then since the audiences are less, we might want to reduce the entire duration of the session. But from our side, our team would anyways be sharing with you a link by 10:30 or so, and they'll be continuously posting it multiple times, and hopefully, people will like it and enjoy. Okay. Thank you, Anand. So let me share the screen and let's proceed further. Okay. All right. This is one thing which happened recently in Shadnagar. In a glass factory, there was a blast, compressor blast. And it's made us realize that there are a lot of such activities or such blasts which are happening across India and in other parts of the world as well. So we were thinking out a lot on how do we address it. And then we came across a good project from one of our clients where the objective was to detect flammable items such as cylinders, shock absorbers, etc., in the scrap. So, in the scrap which was available, we were supposed to detect these kind of items such as cylinders, shock absorbers. And when these kind of, okay, I'll explain the process. Yeah. Typically, what happens is certain steel manufacturing companies, what they do is they get the scrap. They get scrap from the surrounding places. And this scrap, they put it into a burning furnace. And once you put the scrap into the burning furnace, it will result into molten steel. Okay. That's the raw material, molten steel. This is then used to make the steel pipes. This is the process. However, the challenge is this part, burning furnace. If by mistake cylinders or shock absorbers or these kind of items go into the burning furnace, it will create a huge blast, killing people. Okay. So, how can you avoid that? How can you save human lives? You can save it by detecting these kind of items, which probably humans might not be able to figure out. Human beings sometimes, because of lack of, some zeal to detect all these small components, or because of lack of time, they usually do not detect such things. But when we use our AI solution, it detects, right? But anyways, so this is a process. And the business problem here, if we were to implement CRISP MLQ, phase one here is business and data understanding. In this, the business understanding part of it would be first, identify what is a business problem. The business problem here is that if flammable items go into the burning furnace, it's going to create a huge blast, thereby leading to loss of human lives. Okay. So you need to identify that. Next, you also need to detect the business objective. business objective here is to reduce the loss of human lives or reduce the number of blasts that happen in a manufacturing plant. And the third thing is define your success criteria, in which you need to you need to define business success criteria, machine learning success criteria, as well as economic success criteria. You need to define all the three success criteria. Then you go ahead with the data understanding, where you go and collect the data to solve your business problem. Here we have collected the data from CCTVs. Client already had CCTVs. We have taken the videos from CCTV. From CCTV, we have taken the videos. Then once again, what is phase two? Phase two would be data pre-processing. In data pre-processing, you take the video, split it into images, and then you resort to annotation like this. You put a bounding box and say that there's a cylinder. You put a bounding box here and say that there's a shock absorber, right? So you perform data annotation. And various other things. I'm just talking about certain relevant things only, right? Then you proceed further with model building. As part of model building, once again, since you're dealing with video, anytime you deal with video or images or audio or textual data, unstructured data, go ahead with deep learning algorithms. Simple. Within deep learning, again, this is called as object detection. You're trying to detect something, right? So this is called as object detection. In object detection, we use techniques such as YOLO model and all. Once this is done, the next phase is called as evaluation, where you need to evaluate business success criteria, machine learning success criteria, and economic success criteria. Okay. And for machine learning, you use different things. It's not accuracy. You use things such as mean absolute precision, etc. Once you're done with the evaluation part, you go ahead with deployment. Though we deployed the solution on cloud, we also did an edge-based deployment of putting the model on the CCTV. Once you put the model on CCTV, it's called as edge-based deployment, where you have to perform model compression, etc., and then deploy it. Post that comes this particular step, which is called as monitoring and maintenance. Continuously, you need to monitor whether you have the right quality of the data continuously coming in or not. Because CCTVs get damaged, right? Because of dust or whatever, it might stop capturing the right data. So you have to continuously monitor. And then you also have to continuously monitor the model drift. Is the accuracy dropping eventually, as in how we put this, right? So these kind of things are very important. Okay. So this is yet another project which we have just discussed. A few of the people are asking questions on participation certificate, etc. There will be a link which our team is going to post. Our team will post at around 10:30. And once our team posts at 10:30, the attendance link, you'll be able to give your attendance. And once you give your attendance, you can You will get the certificate, participation certificate. I'm just informing our team also. Okay. As of now, we have only a few internships, Rajesh. You might want to enroll for one of the internships. If there is anything on MLOps, we'll let you know. But you can always reach out to us. If you truly have a potential, okay, then we would like to give you some opportunity. But we also need to assess whether you really have that potential or not, right? Okay. So let's go ahead and discuss one more use case here. I'll skip this. How to load. I'll show you something if woman interesting. Okay. So this is a project that we have done in the space of healthcare. Okay, after this, I'll give you one example, one or two examples pertaining to generative AI. And with that, we can conclude, friends. Yep. And thank you so much and happy Teachers' Day once again to everyone. Nowadays, because of the changing environment, too much of pollution, too much of office stress, everyone is becoming very workaholic. I am one of the workaholic guys, but yeah, it depends on what makes you happy. You pursue that route, but what is happening is because of the changing lifestyle, because of pollution and all that, because of excess stress, people are not having babies through natural process. They're having some or the other health complications. And people are resorting to assisted reproductive techniques. Assisted reproductive techniques. And one of those techniques is called as IVF. IVF stands for in vitro fertilization. As part of IVF treatments, what they do is you take the sperm from male and oocyte from female, you fertilize it outside to form something called as embryo. And then this embryo is implanted into the woman's womb. And woman would, after a few days, come to know whether she's actually pregnant or not. If she's pregnant, good. But in most cases, the success rate is limited. So if she realizes, woman, that she's not pregnant, again, what happens? They clean the woman's womb and this cycle repeats. Cycle 2, cycle 3, cycle 4. Every cycle is a costly affair and it causes a lot of mental strain on the human health. Okay. So what we have done is we built that's a business problem. Again, I'll take you guys to the route of CRISPR-MLQ through the lens of CRISPR-MLQ. Phase one is again business and data understanding. Business and data understanding. As part of this, the business problem is that success rate of IVF treatments or assisted reproductive techniques is very limited. So you first record the business problem. Once you record the business problem, you record the business objective. Business objective is to maximize the success rate of assisted reproductive techniques such as IVF. Then you also record the success criteria. Remember, very important thing is to acknowledge the fact that When it comes to success criteria, you first need to record business success criteria, then comes machine learning, and then comes economic success criteria. Okay. So in that order, in that sequence, because more emphasis should be on business and economic success criteria than machine learning. I'm not saying machine learning success criteria is trivial, but business and economic are more important than machine learning. Then you proceed further with data understanding. So here we went to the doctor, we went to a hospital, we tied up with that hospital. Then we got access to data. Data is very secure. It comes to you in archived formats, securely encrypted. Then we took help of embryologist, doctor, MBBS and MD, right? MBBS graduation, then they would also have done MD. We sat with the embryologist and labeled the images, whether that's good image or bad image in that way, right? So that's part of your data preparation or data pre-processing, where we have done all the labeling. Okay, we labeled each and every image on whether that is good or bad, viable or not. Okay, then we move to the third phase, which is modeling phase. That is model building. Here, we again resorted to deep learning algorithms, but just for a change, it's not object detection, it is image classification now. It's image classification. As part of image classification, you need to classify whether this image is viable or not. Viable or not viable. Meaning, will it result into pregnancy or not? That's the thing, whether it is viable or not viable. Then we went on to evaluation technique. Here it is typical accuracy, how accurate the model is, not mean absolute precision, or mean absolute recall. It's typical accuracy. But in evaluation phase, you also need to evaluate business, machine learning, and economic success criteria. All these also should be evaluated. Then comes the deployment part. We have deployed this solution on Amazon Web Services on cloud. So that means doctors just need to enter that URL, upload the image, and click on process, and that's it. They'll be able to see the results. Let me show you that. So this is the image of embryo. You just have the browse files option. You browse, upload your embryo. And then it would take a while because it's image that is getting processed. And you also come to know what is the accuracy of these embryo images. Okay, this is the embryo image. There you go. There is 72% probability that it is bad. So these kind of details will come to me. Okay, and based on this, the embryologist might say that, you know what, there's only 70% chance. Let's not go ahead. Only if it is more than 85%, 90%, then we'll go ahead. It depends on the consultation with the patient. Absolutely, right? So one more very important step, last phase. No one should forget this, right? What is that last phase? The last phase is monitoring and maintenance. It's not a one-time journey. You need to continuously perform monitoring and maintenance. Okay. So that marks the end of yet another business problem that we have solved. This is done in consultation with doctors. Medical Council of India also is onboarded with this thought that we are working on this project. We applied for BIRAC grant, and we are affirmatively in the next stage. Once we get to know the result of whether we won that grant or not, we will certainly keep you all posted. Okay. Also, a few of you all were asking for the link to register to get the certificate. The link is posted. You might want to register. Okay, I'll just give you a quick 1-2 minutes. People who register will get the participation certificate that you participated in this event. A few of you all have, I think, dropped off midway or having some net issues. We'll consider all those scenarios, and everyone who attended, even for a brief period, would certainly get the certificate. Don't you worry about that. Okay. So one last use case, and then we can wrap it up. Yeah, by the way, since you all are there on the YouTube, I recommend you all highly to just subscribe. We'll be doing a lot of such sessions moving forward, but if you subscribe, that also motivates us, right, to conduct a lot of such events. So I would now walk you guys through the journey of generative AI and other models. Just give me a minute while I try to get you guys up to speed on a few GenAI projects. Yeah, you just need to allow me a minute. While I try to show you one of the GenAI solutions. If woman is not pregnant, okay, hopefully you are able to see my screen. This will be the last project that I'm going to demonstrate here. Gen AI, a practical view. Okay. Also on LinkedIn, we are posting a lot of details for studying and for you to, enhance your skills. I would highly recommend you all to please go to our LinkedIn page, which is posted on the chat of YouTube. Okay. And please just follow or subscribe our channel so that whenever we post anything meaningful pertaining to your upskilling on AI and generative AI, you immediately are notified. And that is how you continuously keep your knowledge levels up. So that's one thing that I would strongly recommend. So let me now share my screen yet again, and let's proceed further. Okay. So, friends, we built a generative AI model for one of the hospitals. And this is done through one of the startups, which is called a SteadFast. SteadFast is a startup in the space of life sciences healthcare. And we partnered with them. I'm also on their board. So we partnered with them and we built a bot, which is called a SteadFast bot. In this SteadFast bot, which is built based on large language models, which are trained on medical literature. Okay, on medical literature, we have built the bot. Like we used PubMed GPT, we used BioGPT, BioBird, all these things, right? And then we gave a provision for all the doctors of hospitals to quickly come up with a referral letter. Okay, you just need to click on this prompt. This prompt will appear here. Then you need to change the medical condition. Carcinoma, right? Or some kind of cancer. Those details, if you mention and submit, you get the results. which will be generated response. So your referral letter can be generated within seconds. Okay, next. You can also come up with a discharge summary for patients. Okay, where you just need to put your medical condition, and then discharge summary will be generated automatically. Or post discharge care instructions. You just need to use this prompt, change the condition, and you'll get it. And all these responses or these instructions, etc., which will be generated, will be in line with clinical practice guidelines and in line with the hospital literature. All these hospitals will have their own standard rules, their own standard processes that have to be followed. So, be it referral letter or discharge summary or post discharge care instructions, those will be generated. Okay, those will be generated based on that literature. So, all these are already fine tuned. Okay, so hopefully these details help you. So, what is the difference between AI and generative AI? All the use cases or projects that we have shown until now are AI related, your traditional AI. Generative AI means it is going to generate some text or some images, etc. In this case, our generative AI project generates the text. So it depends on whether it is AI or generative AI. So with this, I'll stop. Okay. And I will take your questions if there are any. Please make best use of our learning resources. We have a lot of amazing learning resources available. You as faculty can absolutely leverage upon that. Okay. So what is the difference between AI and LLM? That is what Mohan is saying. LLM stands for large language model. It is called as large because it is trained on huge amount of data and it has a lot of parameters. There's something called as parameters, which the model learns. Parameters or weights. Uh, since the weights are too many, it's called as large language model. Language model because it is learning languages. For example, it learns the English literature from Wikipedia and all the other forums. And then when you type any question, it will give you the answer. That is large language model, like ChatGPT is a large language model. But it is an AI application only. So AI is a large component. Within this AI space, we have a small thing called as generative AI. And generative AI applications are built using large language models. Okay, hope that answers your question. So AI can be anything. AI can be detecting the objects in an image, classifying the image, doing some predictions. Everything is part of AI. Within AI, you have machine learning, which are algorithms which are built, which you use to build AI applications. Within machine learning, again, you have something called as deep learning. Deep learning is a subset of machine learning algorithms, which is used to deal especially your unstructured data. Within deep learning, you have generative AI, which is a different branch altogether. And generative AI applications are built using large language models. Okay, hope that helps, Mohan. Any other questions, friends, that you have? The link is posted. I request you all to click on that and quickly provide your details. And we'll be making use of those details to share with you the certificate, participation certificate. Yeah, Annie, everything is available in that. I just request you to quickly, access the resume optimization hub. RO hub is what we call. It's there on Annie. It is there on the learning resources. You just go there, upload your resume and job description, and every other step will be automatically generated. Okay, you'll also be able to get a cover letter, resume, all those things. You just explore it once. If you have any doubts, you can reach out to our team and they'll help you. Yeah. So what we do is we also have come up with a lot of mind maps. Okay. Um, Let me share that with you guys. For example, right? Once again, I'll go to 360digitmg.com. You have something called as learning resources. In that, if you just scroll down here, and once you get to core learning resources, go to career advancement, conceptual understanding. There you will see mind map. When I click on this, okay, you will see a lot of mind maps, and you can also access the Python programming fundamentals. So if that's the question that you have, right? All these. And in a very comprehensive manner, we have given all the details. Loops, what do you mean by finite loop, infinite loop, break, pass, continue, so on and so forth. All the details. What are the key libraries that exist? Okay. Technology, see, certain things I'll not be able to disclose here, Annie, but we used a GenAI based solutions for resume optimization hub. Okay. It is our proprietary. If you go to learning resources, go to this polish your resume optimization hub. And when you click on get started for free, you'll be able to access it, our RO hub. And you can just scroll it to get more understanding. The moment you click on get started, you just need to upload your resume. You need to paste the job description, compare now. It will do a quick comparison and tell you what percentage of your resume is in line with the job description. So this will help your resume get shortlisted quickly. And in this, we gave a lot of other options for generating your cover letter, then generating interview questions. All that I can say is created using GenAI. We used a lot of open source large language models. And so hopefully that helps. For machine learning and deep learning classes, how to purchase courses are free. See, free we will give only a few, but you have to enroll for a paid program to actually get maximum benefits. We cannot give everything for free because we have a lot of people who are working with us who are generating such amazing content and applications. We need to pay salaries to them, right? It's not possible otherwise. Okay. Thank you so much, friends. Hopefully you have enjoyed. There's a lot of content that we have created. Please go to 360DigiTMG and learning resources. Spend some time on that and start exploring all the various options. All the best. And thank you so much again. Happy Teachers Day. And thank you so much, all the teachers, for continuously supporting the workforce of India. Thank you.